next speaker here, very nice. It's Richard Dawson from LiNa Energy. He's the CTO, and he will give us a presentation about sodium batteries. Very looking forward for your presentation, and thank you.
Well, thank you very much. Yeah, it's a pleasure to be here from the always warm and always sunny northwest of England. So I'm going to give you a bit of an overview of LiNa Energy, what we're up to, and some of the kind of aspects of our cells as well, which I hope you find interesting. So a few things to start off with, which I'm sure you're all very aware of, but we're all pretty clear that batteries are going to be a really big, I mean, they're already a big part of our transition towards a greener future, but we need bigger batteries, we need better batteries, and we need lower cost batteries for all sorts of applications. Now, I'm not saying that lithium is bad. I'm a sodium proponent, but I'm not saying lithium's bad. I'm just saying it's such a big market, it's such a big need that lithium surely can't be the answer to everything. And when we look at lithium technology that's used at the moment, I know we're at solid state lithium, solid state conference, but when we look at just things like the sustainability of it, it can't answer all the needs. So you look at the price of lithium; it's gone up hugely in the last few years. And the actual price of the cells, maybe they're artificially low at the moment. In terms of conventional lithium-ion cells, it's only going to get worse. We also know that there are some safety issues around lithium cells, conventional lithium-ion batteries, which of course why we're talking about solid state. And we know that there's some performance limitations. And of course, all of this comes with a cost impact in terms of sustainability, resources availability, in terms of engineering around some of the safety issues that you have with conventional lithium-ion cells. So what are we doing in the space? So we have a sodium based cell. So we have little cells like this, which is our sort of smallish first generation cell, which we know when we look at it in terms of scale, can potentially have a very low cost. And we'll look at what's actually inside it in a moment. The performance of it has some really quite high levels which we can achieve. So we don't have some of the same energy density ceilings that you have with conventional lithium-ion. We can have some very high system efficiencies as well. And in terms of the sustainability, the raw materials which are inside these cells are much easier to source from around the world, much more sustainable, much more widely available. So we can have domestic supply chains, and we're not reliant on sources which are located in certain geographic regions. And when you actually look at the chemistry, it's inherently safe as well. So lots of the good things that you might expect from a largely solid state battery. So yes, you can see this is a genuine little cell here, which I've got in my hand, and that's one picture there. Okay, so what is it we're actually got inside this cell? So it's a proven chemistry, so it's not actually a new chemistry. So it's sodium metal chloride chemistry. So it's been around since the 1980s, or actually a little bit earlier. But what we've actually done is we radically re-engineered the cell and the configuration of it. So we're at LiNa Energy. So we have a background in energy devices, in batteries, in fuel cells, and solid oxide fuel cells as well, and ceramic processing to make ceramic solid state devices. So we looked at what has been going on in other parts of electrochemical energy technologies, and we've applied some of those learnings that we had into the sodium metal chloride cell. And so at the heart of our cells, we have a very thin solid state conductor, which is a metal supported conductor, which is what we're developing. So that's what I have in my hand here as well. You can sort of see this is what's inside these cells. So what does that do for us? It gives us a really nice, robust little electrolyte. This is, as I say, it's our first sort of generation demonstration cell. So it's a capacity of similar to an 18650 cell. So it's not a huge cell, but it is a good working cell. And that gives us the ability to go to higher energy densities, be a lot more robust, planar, makes it very simple to make as well. So that's what we're doing. Which gives us this potential to go to very low cost as well. So if those of you who aren't familiar with the chemistry, this is what goes on inside the cell. So we have all our active materials, which are sodium chloride and a metal, which can be iron or nickel. And on charge, we produce nickel iron chloride and sodium metal. And so you can see the voltages